Hello, everyone. If you're watching this, it means that that's good. All right, let's go ahead and begin. We're going to go ahead and start our chapter 1 of calculus, which is limits and continuity. Okay. Before we begin, we're going to go ahead and do a quick review about our evaluating functions. So let me go ahead and do this real quick. So take a couple seconds to pause the video, give these questions a try. And we have f of 3. So pretty straightforward. It's asking us to evaluate this function that they gave us at 3. So we would just substitute 3 into here. So we would be 3 cubed minus 1 divided by 3 minus 1. We can see that 3 to the third power is 27 minus 3 over 3 minus 1, which is 2. So we have actually 25 over 2. Okay. The next one has evaluating the function at the -2. So the same procedure, -2 to the third power minus 1 over -2 minus 1. This simplifies to that -2 to the third power. So this gives us -8 minus 1 over -2 minus 1. That gives me a -3. If I continue to simplify this down, this gives me a -9 over a -3, which simplifies to a +3. And last but not least, we have the function evaluated at 1. So if we do that, we see that f of 1 is going to be equal to 1 cubed minus 1 over 1 minus 1. Hopefully you're able to see that we have 0 over this minus 1. This +1 minus 1 gives me division by 0. We cannot divide this. Is actually indeterminate form, which we will learn how to simplify, but as of right now, we do not know what this is. Okay, so this is hopefully this is a little intro of what we will be seeing, and we're going to be wondering why this one did not work. Hopefully some of us were able to see that, hey, doesn't this give me that vertical asymptote? But we will learn more about this. But if you saw that was a vertical asymptote from the start, you are ahead of the game. Okay. Alrighty. So today we're going to learn about what a limit is. So go ahead and take a couple seconds to write this down. Okay. So when we talk about a limit, okay, we're talking about a function, and we're going to go ahead and get arbitrary close, so really close to a number, right? So this number we'll go ahead and call L, and we're coming in from either side, and we'll be able to distinguish from coming from the left versus coming from the right, or coming from both sides. Okay. So, oops, this should have been C, not an infinity typo. Okay. Here's a different way to see it. You'll be given a function. We are approaching, right, on our domain, we are approaching some value A or some value C, and whatever that our function goes to is what we'll be able to call the limit. Keep in mind, we are talking about approaching from either the left of our domain or from the right of our domain, and we will be getting the limit will be a y value. Okay. Okay. So continuing what a limit is, how can we find it? So most popular will be algebraically, but we will see graphically and using a chart as well. Okay. So let's go ahead and give this a try. Let me go ahead and hide my video. Okay. Alrighty. So we're able to see right here that we want to go ahead and find this limit. Okay. So we're trying to see what is the limit as x approaches. This little arrow tells me to approach. So I'm getting really, really, really close to that -1. And we can see our x equals -1 is this value right here. So we can see there is some sort of discontinuity there. Okay. Go ahead and pause the video and tell me why there is a discontinuity. Okay. Hopefully you were able to see that, hey, if I looked at my function, I got x plus 1 in the numerator, denominator. That means I have a removable discontinuity, or a hole, at x equals, well, we solve for this equal to 0, so x plus 1 equals 0, so x equals -1. So there's a removable discontinuity, or a hole, at x equals -1. Oops, -1. Okay. That will not stop us from getting this limit, okay? But cases may vary. So as the definition said, we're getting really, really close, right? From my my values for my domain. So I'm going to get really, really close from the x values from my left and really, really close. Let me change markers from my left and from my right, right? So I'm going from my left and I'm going to go ahead and check out what is my y value, okay? So as you can see, if I go from my left and I approach this -1, I can see that my y value is this -2. And if I come from my right and I go really close to this x value of -1, my y value is also 2. So we're going to go ahead and say that my limit, right? My limit as x approaches -1 for this function right here is -2, the y value. We're talking about the y value. Okay, so this is how we'll be able to see when we are given a graph. When we're talking about a table, so go ahead and take a couple seconds to write down this example. We can go ahead and use this table and approximate what our limit is going to be. So we get to see right here that the function we are working with is an x squared, and that is a parent function we should all be aware of. That is the parabola. And we want to find out when x equals 3. So when x equals 3, we can go ahead and do something like that. There'll be some y value, right? And we can do this by filling in this table. So let's go ahead and do the first one, 2. So for this function, so I'm going to do 2 to the second. That will go ahead and give me 4. And then we go ahead and do the next ones, 2.5 to the second. And you can go ahead and use your calculator. I believe this is what, 6.25. And we want to get really, really close, right? So I'm going to start putting these 9s right here. So these ones I don't know off the top of my head, but we can go ahead and use a calculator. And what we also need to consider is this is approaching from the left, right? So we're approaching from the left. We also need to do this from the right. So I'm picking values that are a little bit bigger than 3. So 3.001 is a little bit bigger, this 0.01, and then we can go a little bit bigger, 3.01 and then 3.1. Okay, so with the magic of television, we get to see that, and there's a little typo right here, whoops. We get to see that we have this right here. Okay. And if we see that this is approaching 8.99, and if we would have went even closer, this would have been 8.99 and multiple 9s. And if we would have added 3.000s in front of the 1, we got really, really close to this. And you can get a calculator to verify my math. But ideally, what we want to say is that the y value, right? My y value here is this 9. We can double check our work, right? So 3 squared is 9 for this scenario, okay? So as x approaches from the left, right? The limit as x approaches from the left has a little minus exponent, and the limit as x approaches from the right has a little plus. We get to see that they both get really, really, really close to this value of 9. So that's what we're going to go ahead and say is our approximation. Okay. So what happens if the left-hand side, right, the little minus sign, oops, where's my pen? The minus sign is not the same as the exponent coming from the right. So if the right limit and the left limit is different, we're going to go ahead and say this does not exist. The limit does not exist. Okay. So I went ahead and put this little equal sign right here. And there are scenarios where this does not exist, and there are scenarios that we just saw that does exist. Okay. So let's go ahead and check some out. Alrighty. So I have this graph right here. And one of my biggest concerns is, can we identify when they're asking us for a limit, like this second part right here, and when they're asking us just what is a value of f, like our do now. Okay, so go ahead and pause the video and give this a try. Okay, alrighty, f of 3, and I meant f of -3, whoops. F of -3, so sorry about that, try it again. F of -3, what is that y value? So well, at -3, we get to see that there is this asymptote right here, right? This is what this little line means. There's a vertical asymptote somewhere here, well, exactly here. And my graph is doing everything it can to avoid this. So this is, we can see this is a vertical asymptote. we have no idea. We have no idea what's happening at x equals -3. So this what we can say is undefined, okay? How about the limit as x approaches -3? Well, that's when we're trying to get really, really close from the left and really, really close from the right. And we're trying to see, okay, what's going on? So we can see that as x approaches from the left-hand side, we get to see that this graph is going all the way up like so. And we see when we're approaching from the right, we're coming from the right, we see that as I'm getting closer to the -3, my y values are going down, 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 all the way down, okay? So that's what I want you guys to know. So this right here went all the way up from the left, and from the right went all the way down like so, okay? So my left-hand limit, my limit as x approached -3 from the left was not equal to the limit as x approached from the right. Sorry, I almost forgot my negative. Okay, so in this case, does not exist. Okay, but yeah, I went ahead and for the homework, I gave you guys different scenarios of this same question. So give them a try. Okay, hopefully this was a good intro to our limits lesson. I did go ahead and give some practice problems very similar to what we just did. I will try to be available tomorrow for any questions. I know I won't be live, but hopefully this gives us some sort of idea. Okay. I will attach links to different videos that will also help as well. Other than that, guys, I hope this is good, and I'll upload the assignment on Teams. See ya. Take care. Bye-bye.